This Python code is designed to fetch historical stock price data for algorithmic trading purposes, leveraging deep learning techniques. The code uses several libraries such as Pandas, Pandas Data Reader, and Y-Finance to interact with financial datasets and manipulate them effectively. The core functionality of the code is encapsulated within a function named getHistoricalData, which takes a list of ticker symbols as an argument. The function retrieves the adjusted closing prices for each ticker from Yahoo Finance over a specified one-year time frame between November 13, 2021 and November 13, 2022. Adjusted closing prices are commonly used in financial analysis as they account for dividends, stock splits, and other corporate actions that may affect the stock's value. The fetched data for each of the tickers is combined into a single Pandas data frame with each stock's adjusted close prices as a separate column. The column headers are renamed to the corresponding ticker symbols for clarity. This consolidated data frame facilitates further analysis that is typically performed in algorithmic trading strategies, such as computing indicators or training machine learning models. Finally, the script prints the shape of the gathered data to provide insight into the dataset's dimensions and displays the most recent data points gathered using .tail method, which is crucial to assess the current state of the stocks and potentially make up-to-the-minute trading decisions based on the latest information available. The given Python code snippet is designed to visualize the stock price movements of 3 meme stocks, which are stocks that have gained popularity and seen significant trading volumes due to social media and retail investor hype. The stocks in question are GameStop Corp., GME, AMC Theaters AMC, and Bed Bath & Beyond Inc., BBBY. The code makes use of the matplotlib library to plot the stock's price data. It sets up a figure with specific dimensions and resolution, 8 inches by 6 inches, with a resolution of 200 dpi, to ensure the plot is of a certain size and clarity when displayed. For each stock, the code extracts its data from a presumed pre-existing data structure and plots it on a graph. Each stock's line on the graph is labeled with its corresponding company's name. A legend is also added to the plot, which helps viewers distinguish between the lines representing each of the 3 companies. The purpose of this code is to provide a clear visual comparison of the trading patterns of these stocks over time, allowing users, presumably traders or analysts, to identify trends, similarities, or differences in the stock price movements of these popular companies. This kind of analysis could be part of a larger algorithmic trading system that uses deep learning to make trading decisions based on historical price data and predictive modeling. The provided Python code snippet is designed to analyze the percentage changes in the price of a particular stock, in this case GME, which likely represents GameStop Corp. The purpose of this analysis is typically to understand the stock's volatility, which is crucial in algorithmic trading with deep learning, as it can help in creating models that predict price movements, manage risk, or strategize trades. Firstly, the code computes the percentage change between consecutive data points representing price at different times in a dataset named data. It does this for all rows after the first one to ensure it has a previous data point to calculate the change from. Next, it isolates the percentage changes of the GME stock from the resulting data frame. This operation creates a series of percentage changes exclusively for the GameStop stock prices. Finally, the code retrieves the actual values of these percentage changes and calculates their mean average. The output of these commands would provide the user with a sequence of daily percentage changes in the GameStop stock price and the average of these changes, offering a sense of how the stock price typically moves day to day. This information can feed into deeper analysis or be used as input for deep learning algorithms in an algorithmic trading system. The provided Python code snippet is for visualizing the z-scores of GameStop Corporation's GME percentage change in price using a line graph. The purpose of the code is to help in the analysis of the price movements of GME stock and to identify any outliers or unusual behavior in its price changes. The code begins by setting up the size and resolution of the figure that will be displayed. It then calculates the z-scores of GME's price changes by standardizing them using the mean and standard deviation of the data. The z-score represents how many standard deviations away a data point is from the mean. Once the z-scores are calculated, the code proceeds to plot these scores on a graph with labeled axes. It also includes horizontal lines at the mean z-score and at the z-scores of price 1 and 2. These lines represent standard deviation thresholds and are color-coded to highlight regions where a certain percentage of the data is expected to fall under a normal distribution assumption. Specifically, about 68% of the data is expected to lie within one standard deviation marked by green lines, and about 95% is expected to lie within two standard deviations marked by red lines. The graph is then annotated with a legend to clarify the meaning of each line, and a title is added to the plot to describe what the visualization represents. Finally, the graph is displayed. This type of analysis is an essential part of algorithmic trading, allowing traders to quantitatively assess the variability and standardization of financial data, which can be crucial for making informed trading decisions. The Python code snippet you've provided appears to be part of a larger algorithmic trading system that utilizes deep learning techniques. The purpose of this code is likely to perform data pre-processing, model training, prediction, and possibly even executing trades based on the model's output. In the context of algorithmic trading, the code would start by loading and pre-processing market data such as stock prices, volumes, etc., and then feed this data into a deep learning model. This model could be a neural network designed to identify patterns and make predictions about future price movements. The processed data is used to train the model, optimizing its parameters to accurately forecast market trends. After training, the code uses the model to predict new data points, which can inform trading decisions. If the system is fully automated, it could also execute trades based on these predictions, buying or selling assets in a financial market in a manner that aims to maximize returns. This snippet is a small part of a complex system that requires rigorous testing and validation to ensure it operates effectively within the highly volatile and unpredictable domain of financial markets. The provided Python code snippet is used to calculate the momentum of financial assets, such as stocks, over a specific number of days. The concept of momentum, in this context, refers to the rate of acceleration of a security's price or volume. The idea is that assets experiencing positive momentum tend to keep moving in the same direction, and this strategy can be used to predict future price movements. In the snippet, the pandas library's diff function is applied to a data frame named data that likely contains historical stock prices. The diff function calculates the difference between the current row value and a subsequent row's value specified by the argument passed to the function, in this case, 10. This means the code is calculating the difference between the current day's price and the price after a gap of 10 days, which serves as a basic way to measure the asset's price momentum over that 10-day period. The resulting differences are stored in the variable data mi, which then can be used for further analysis or as part of an algorithm in an algorithmic trading strategy. By analyzing these momentum indicators, the strategy may signal if it's potentially a good time to buy or sell based on whether the momentum is positive or negative. The code is a small part of the larger framework of using deep learning for algorithmic trading, where such features might be inputs to a machine learning model that predicts price movements. The given Python code is intended for visualizing financial data, which is a common preliminary step in the process of algorithmic trading with deep learning. Specifically, this code snippet is used to create line plots of individual stock data over time, allowing the user to examine the performance and trends of different stocks. The code creates a figure with a specified size and resolution, then retrieves stock data for GameStop Corp., GME, AMC Theaters, AMC, and Bed Bath & Beyond Inc., BBBY, from a larger dataset. It plots the data for each of these companies on the same graph, with each stock distinguished by a label. Finally, it adds a legend to the plot, which helps to identify which line corresponds to which company. This visualization is useful for assessing how these stocks have moved in relation to each other over a specified time frame, which can inform trading strategies and the development of predictive models in deep learning. The provided Python code snippet is related to plotting stock price data for algorithmic trading with deep learning. The code first sets up the dimensions and resolution of the plot using the figure function with an 8 by 6 inch figure at 200 dots per inch DPI. The snippet extracts historical stock price data for 3 companies, GameStop Corp., AMC Theaters, and Bed Bath & Beyond Inc., from a larger dataset, likely a multi-index data frame named data.my. It then proceeds to plot the price data for each company on the same graph for comparison, using labels to identify each company's data line on the chart. The code also adds a legend, which helps with identifying the plotted lines corresponding to each company's stock. The comment in the code explains that in the context of algorithmic trading and market sentiment analysis, data points above the zero line in the plot can be interpreted as bullish momentum, indicating upward price movement, while points below are considered as bearish momentum, suggesting downward price movement. The visual representation of these trends can be valuable for making informed trading decisions. The provided Python code is an initialization snippet commonly found at the beginning of a script related to algorithmic trading with deep learning. It is intended to set up the environment by importing necessary libraries and configuring visualization parameters. Firstly, the code imports the matplotlib.pyplot module under the alias PLT, which is a widely used library for creating static, interactive, and animated visualizations in Python. It's crucial for plotting stock price charts, performance metrics, or any other visual data analysis relevant to trading algorithms. Secondly, the code imports the Pandas data reader library as PDR. This library provides functions for reading financial data from various sources directly into a Pandas data frame. It's essential for algorithmic trading as it can be used to fetch historical stock price data, economic indicators, or other financial information that could be input for deep learning models. Thirdly, it imports the datetime module as DT. Datetime module is used to handle dates and times in Python, which is a necessity when working with historical price data, managing time series information, and setting up time-based events for the trading algorithm. Lastly, the code sets the default figure size for matplotlib plots to a large size of 2010 inches. This adjustment ensures that the generated figures are big enough for detailed analysis, making it easier to notice trends, patterns, and outliers in the visualized data. The purpose of this code is thus to prepare the Python scripting environment for data acquisition, visualization, and time management, all of which are fundamental components of an algorithmic trading system using deep learning models. By setting up these elements at the top of the script, the user ensures that the necessary tools and configurations are in place for the subsequent data analysis and model building processes. The Python code presented is used to obtain historical stock price data for Apple Inc. with the stock ticker AAPL from a source such as Yahoo Finance. The module PDR from Pandas data reader is used to access financial data codematically. The getDataYahoo function takes 3 arguments: the stock ticker symbol, the start date for the data retrieval, and the end date, which is set to the current date using dt.datetime.now. In this instance, the code is fetching data from October 29, 2021 to the present day. The purpose of this code is to gather historical stock price data, which is a common first step in algorithmic trading and deep learning models related to financial market analysis. The data acquired will likely be used for training a machine learning model, conducting technical analysis, or backtesting trading strategies. The model could make predictions about future stock price movements, formulate buying or selling decisions, or test hypotheses about market behavior. This Python code is designed for algorithmic trading using a deep learning approach and calculates the stochastic oscillator indicator for stock data. The stochastic oscillator is a momentum indicator that compares a particular closing price of a stock to its price range over a certain period of time. The code calculates two lines, namely cent K and cent D, where cent K is the current value of the stochastic indicator and cent D is the 3-period moving average of cent K. It first determines the highest and lowest prices within a 14-day window. It then computes the cent K value based on the stock's closing price and the established high and low prices within that window. The cent D line is calculated as the simple moving average of the cent K values over a 3-day period. The code represents these calculations graphically, plotting both the cent K and cent D lines alongside the stock's adjusted closing price. Buy and sell signals are inferred from the crossovers of these lines. A buy signal occurs when cent K crosses above cent D, and a sell signal occurs when cent K crosses below cent D. Additionally, the code shows horizontal lines at the 20 and 80 levels, indicating traditionally oversold below 20 or overbought above 80 conditions. The provided website URL is likely a resource or tutorial related to the computation of the stochastic oscillator in Python using the pandas library. The final comment in the code cautions users that the stochastic oscillator, like all indicators, is not a foolproof predictor of market movements. Instead, these signals should be used in conjunction with other market analysis factors to inform trading decisions. This Python code imports the pandas TA library, which stands for Pandas Technical Analysis. This library is an extension for pandas, a popular data analysis and manipulation library, and is specifically designed to provide tools for performing technical analysis on financial data. Technical analysis involves analyzing statistical trends gathered from trading activity, such as price movement and volume, to identify trading opportunities. The purpose of the Pandas Data library is to make it convenient to apply a variety of technical indicators and analysis techniques to historical market data. By doing so, it allows traders and analysts to obtain insights into the market's potential movements and make informed decisions on their trading strategies. Given that the context is algorithmic trading with deep learning, the inclusion of this library suggests that it's being used to pre-process financial data, generate features, or construct technical indicators that may serve as inputs for the deep learning model. The model could then use these inputs to predict market trends, identify trading signals, or optimize trading strategies. The provided Python code snippet is a part of a deeper algorithmic trading system that utilizes deep learning. It defines the calculation of the relative strength index RSI for a financial asset like a stock or currency pair, which is a popular momentum indicator used in technical analysis to measure the magnitude of recent price changes and determine overbought or oversold conditions. In this snippet, a pre-existing data frame named ticker is used, which contains historical trading data. The RSI function from the Pandas TIA library is called with two parameters. The first parameter, ticker jClose, specifies that the adjusted closing prices from the ticker data frame should be used for the RSI calculation. The second parameter, length 14, sets the period over which the RSI is calculated, which is the standard period of 14. The result of the RSI calculation is then added to the ticker data frame as a new column named RSI. Traders and automated algorithms can subsequently use this RSI column to make decisions about when to buy or sell the asset, as RSI provides signals that may indicate potential reversals in the asset's price trend. The provided context suggests that the code snippet is part of a larger code base which performs algorithmic trading using deep learning techniques. The code likely includes functionality to process financial data related to specific securities or assets identified by their ticker symbols in order to make informed trading decisions. The term ticker typically refers to a ticker symbol, which is a unique series of letters assigned to a security for trading purposes. In this context, the ticker would be used to fetch historical price data, real-time quotes, or other relevant financial information for a given asset from databases, APIs, or financial data services. The deep learning component of the code probably involves creating predictive models that analyze historical price data and other relevant financial indicators to forecast future price movements. The predictive outputs of these models could then be used to devise trading strategies, deciding when to buy, hold, or sell an asset, with the goal of maximizing returns while managing risk. Given that this is algorithmic trading, once a strategy is defined, the code would automate the process of executing trades based on the signals generated by the deep learning model, allowing for rapid and systematic trading that can take advantage of market conditions more quickly than manual trading. This Python code snippet is part of a larger algorithmic trading application that uses deep learning. The code is responsible for visualizing the relative strength index RSI of Apple's stock. The RSI is a momentum indicator used in technical analysis to measure the speed and change of price movements. The code snippet utilizes a data frame ticker which presumably contains financial data for Apple Inc., including the RSI values. It creates a plot of the RSI over time, where the x-axis represents dates and the y-axis represents the RSI values. The plot is given a title, Apple Stock Adjusted Close RSI Signals. To enhance the visualization, two horizontal lines are added using plt.xhline. These lines represent the commonly used thresholds in RSI analysis, a value of 30 and a value of 70. The line at 30 is styled with a green dashed pattern indicating the level below which the stock may be considered oversold, and the line at 70 in a red dashed pattern indicating the level above which the stock may be considered overbought. Finally, plot show is called to display the resulting plot. The purpose of this visualization is to aid traders in making decisions by identifying potential buy or sell signals based on RSI readings. Typically, an RSI below 30 suggests a potential buying opportunity, whereas an RSI above 70 may suggest a potential selling opportunity. This Python code snippet imports a module named wrap from a package called StockStats. The StockStats library is designed to assist in financial analysis and algorithmic trading by providing a variety of stock market indicators often used to analyze stock price data. These indicators can include things like moving averages, relative strength index RSI, and others that traders rely on to make informed decisions. The purpose of importing the wrap function in the context of algorithmic trading with deep learning could be to transform raw stock data into a format that is more suitable for conducting technical analysis. Once the data is wrapped appropriately, deep learning models can then be applied to detect patterns, predict future price movements, or generate trading signals. In an algorithmic trading system, such features and transformations are crucial as they can greatly enhance the predictive model's performance. By utilizing historical data and various financial indicators, the BOS system aims to automate the trading process based on the insights gained from the analysis. The StockStats library, therefore, serves as a tool in the pre-processing stage, setting the stage for further analysis using deep learning algorithms. This Python code aims to retrieve stock market data for a specific publicly traded company, GameStop Corp., ticker symbol GME from Yahoo Finance. It uses the Pandas data reader library, often abbreviated as PDR, which provides the function getDataYahoo to fetch historical data for stocks, indices, ETFs, and other financial instruments. The function getDataYahoo is called with 3 arguments. The first argument is the ticker symbol GME, which represents GameStop Corp. on the stock exchange. The second argument is a datetime object representing the start date from which to retrieve the historical data, which is October 29, 2021. The third argument is another datetime object representing the end date, which in this case is the current date and time as returned by dt.datetime.now. Once the function is executed, it will reach out to Yahoo Finance's API and download the historical data for GME between the specified start and end dates. The data would typically include information like the opening price, the high price, the low price, the closing price, the adjusted closing price, and the volume of shares traded for each day. The snippet concludes by storing this fetched data into a variable ticker, which can then be used for further analysis or processing. In the context of algorithmic trading with deep learning, this historical data might be used to train a model to make predictions about future stock performance, execute trades based on strategies, or analyze the stock's movements for research purposes. The Python code snippet type ticker calls the built-in function type, which is used to determine the data type of the variable ticker. When the function type is applied to ticker, it returns the class type of ticker. This could return a class indicating that ticker is an integer, float, string, list, or any other data type available in Python. The purpose of this specific line of code in the context of algorithmic trading with deep learning is likely to ensure that the ticker variable is of the expected data type before it's used in any trading algorithms or data processing steps. In financial data analysis, a ticker usually refers to a stock symbol representing a particular stock on an exchange. Ensuring the correct data type is crucial for the code to be able to use this variable correctly, whether it's for fetching stock prices, making predictions with a deep learning model, or executing trades. The provided Python code snippet seems to be a part of a larger code intended for algorithmic trading using deep learning methods. In the context of financial markets, ticker often refers to the stock symbol or ticker symbol that uniquely identifies a publicly traded company's stock. The word ticker here, however, is used as a variable name for a data frame object that contains historical stock market data. This data frame is assumed to be pre-sorted and includes several common financial metrics such as date, closing price, high price, low price, and trading volume. Each of these features is critical for analyzing stock performance and making trading decisions. The code creates an instance named GME using a function called wrap. Though the function is not defined in the snippet, we can infer that wrap takes the dataframe ticker as an input and performs certain operations on it, likely related to preparing the data for the deep learning model. This could involve normalization, adding technical indicators, or creating additional features derived from the existing columns. Finally, GME is the result of the wrap function, which now holds the processed data for the game retailer GameStop, indicated by the usual stock symbol GME. This pre-processed data will then likely be used to train or make predictions with a deep learning model, which aims to identify patterns and make informed trading decisions. The end goal is to automate trading actions based on the model's predictions to potentially capitalize on the financial markets. This Python code snippet is invoking the type function on the variable GME. The purpose of type is to return the class type of the argument passed to it. In this context, GME is likely a variable that holds some value or object, and when the type GM expression is evaluated, Python will return the data type of GME. The meaning of GME in this snippet is not immediately clear without additional context, but given that this code is part of an algorithmic trading with deep learning algorithm, GME could represent data related to GameStop Corp., which is a well-known ticker symbol for this company on the stock market. For example, GME could be a pandas data frame object containing historical stock prices for GameStop, a NumPy array with trading signals, or another type of data structure used within the trading algorithm. The outcome of this operation would provide the developer with information on what kind of data structure they are dealing with, which is particularly useful for debugging, ensuring correct functionality, or simply understanding the flow of the code within the algorithmic trading system. Identifying the type of GME would also help in determining what operations can be performed on it and how it fits within the broader deep learning model or trading strategy. The Python code you're referring to is part of a larger script that's used in the context of algorithmic trading with deep learning. This particular line is meant to extract the MACD value from a data structure, which is presumably a pandas data frame containing stock information for GameStop Corp. GME. MACD, or Moving Average Convergence Divergence, is a trend-following momentum indicator that shows the relationship between two moving averages of a security's price. The MACD is calculated by subtracting the 26-period exponential moving average EMA from the 12-period EMA. The resulting value MACD is often used in trading to signal potential buy or sell opportunities based on crossovers and divergence with the stock price. So, in essence, the line of code in question is grabbing previously calculated MACD values for the purpose of analyzing GME stock for trading decisions in an algorithmic trading system that likely uses deep learning to predict future stock movements based on historical data and technical indicators. The provided Python code snippet is extracting a series of values from a dataset or a data frame named GME, which likely contains stock market trading data for the GameStop Corporation, represented by its ticker symbol GME. The code is specifically accessing a column or key named MACDs, which stands for Moving Average Convergence Divergence Signal Line. The MACD signal line is a trend-following momentum indicator that shows the relationship between two moving averages of a security's price. It is typically calculated as the exponential moving average EMA of the MACD values over a period of 9. In the context of financial trading, investors use the MACD signal line to identify bullish or bearish momentum in the stock price and generate signals on when to buy or sell. The purpose of the code is to isolate the MACD signal line values from the GME dataset so they can be used as part of an algorithmic trading strategy. By analyzing this line with respect to the MACD line itself or the stock price, an algorithm might make decisions to execute trades based on expected price movements inferred from historical patterns. This snippet is a likely part of a larger algorithmic trading system powered by deep learning techniques used to predict market trends and improve the timing of trading decisions. The Python code snippet is part of a larger script concerned with algorithmic trading using deep learning methods. This specific line extracts the MACEH series from a data frame called GME, most likely representing stock data for GameStop Corp., given that GME is its ticker symbol on the stock market. The MACDH is short for the MACD histogram, which is an indicator used in technical analysis for securities trading. The MACD histogram is computed by taking the difference between the MACD line, a fast-moving average, and the signal line, a slow-moving average. This histogram is used by traders to identify momentum and potential buy or sell signals based on the convergence and divergence of these moving averages. In essence, the extraction of the MACDH value from the GME dataset suggests that the code will use the MACD histogram as a feature or a signal in the context of an algorithmic trading strategy, potentially incorporating deep learning models to predict future price movements or to make trading decisions. The code provided is a function designed to plot the moving average convergence divergence MACD indicator alongside stock prices. The function takes 4 arguments: prices, which is the stock price data, MACD and signal, which represent the MACD line and the signal line of the MACD indicator, and hist, representing the histogram of the MACD, which is the difference between the MACD and signal lines. The purpose of this code is to visualize the stock price along with the MACD indicator for algorithmic trading analysis. This can help traders or algorithms to make decisions based on the visual representation of the market momentum and trend changes. It uses a 2-panel plot layout where the stock prices are plotted on the top panel and the MACD indicator is plotted on the bottom panel. The MACD line, signal line, and histogram bars are drawn with distinct colors for better clarity. The histogram bars are colored differently depending on whether their value is negative or positive. Additionally, a legend is included in the lower right of the plot to help differentiate between the MACD line and the signal line. The plot is likely intended to be used as part of a larger algorithmic trading strategy that utilizes the MACD indicator, which is a popular technical analysis tool used to detect changes in the strength, direction, momentum, and duration of a trend in a stock's price. The given Python code snippet is specific to the domain of algorithmic trading, which leverages deep learning. The function plotMACD is designed to visualize the moving average convergence divergence MACD indicator, which is a popular tool used by traders to understand market trends. This function takes 4 parameters: prices, MACD, signal, and hist. Here, prices represents the adjusted closing prices of a stock, which is a common input for financial analyses, since it accounts for corporate actions like splits and dividends. The MACD parameter denotes the MACD line values calculated from the stock prices, typically by subtracting the 26-period exponential moving average EMA from the 12-period EMA. The signal parameter refers to the signal line, which is essentially a 9-period EMA of the MACD line itself. It acts as a trigger for buy and sell decisions. Lastly, HIST stands for the MACD histogram, which represents the difference between the MACD line and the signal line and can indicate the strength of the price movement. The purpose of this code is to graphically represent these elements so users can analyze the convergence and divergence of the MACD line with respect to the signal line and observe the histogram, which can give insights into the momentum and potential reversal points in the market. Such a visualization aids in making informed trading decisions based on the momentum and trends identified by this technical indicator.